Let's go through the study guide for your upcoming test, chapters 16 through 19. Here's a list of all of the different types of questions and that you might be asked and things that you should be able to do by the time you take your first test. Let's match these different terms up with their definitions. I'm going to be focusing over on the definition side. A carboxylic acid with a long carbon chain, I know that's a fatty acid. Movement of ions across a membrane from a low concentrated area to a high concentrated area. That's moving against what Mother Nature would like to do, so that is active transport. A molecule that has a carbon atom with two OR groups attached to it. A carbon atom with two OR groups attached. That looks like an acetal. A reaction that converts an aldehyde to a ketone or an alcohol, that's going to be a reduction reaction. That's where we are converting either an aldehyde or a ketone to an alcohol. So that's a reduction, and maybe this is a hydrogen out here. That's when it would be an aldehyde. A naturally occurring amine. I don't think that naturally is supposed to be in there twice. A naturally occurring amine or amide that causes a physiological response in humans, that is the alkaloid. A molecule that contains a nitrogen atom bonded only to carbon atoms, that looks like a tertiary amine. A nonpolar biological molecule is a lipid. A molecule made from glycerol, two fatty acids, and a phosphate group. Glycerol, two fatty acids, and a phosphate group. Ooh, that feels tricky. I feel like I want to come back to that one, so I'm going to circle that so I don't forget it. A double layer of phospholipids. That's our lipid bilayer. A molecule that has a nitrogen bonded directly to a carbon oxygen. So if there's a carbon oxygen with a nitrogen right on it, that is an amide. Where's amide? There's amide. A molecule produced when a long-chain carboxylic acid or a long-chain ester reacts with NaOH. That is how we make soap. A molecule that has an OH group bonded directly to a carbon-oxygen double bond group. That is a carboxylic acid. A molecule that contains a nitrogen atom with only one hydrogen. So that means the other two bonds are to carbon. That's a secondary amine. A molecule that is synthesized in the body to transmit signals from the brain to the organs. That is a hormone. Remember, hormones carry messages far away from the brain to other parts of your body. A carboxylic acid with a second OH group that is adjacent to, but not attached directly to the carbon-oxygen group. So carboxylic acid with a second OH group that's adjacent to it. Woo, that's tricky. That looks like an alpha hydroxy acid, 15, alpha hydroxy acid. Remember, the difference between an alpha hydroxy acid and a beta hydroxy acid is the location of the second OH group. So that would be what a beta would look like. The reaction, 16, the reaction between fat or oil and water and NaOH, that's saponification, the reaction that produces soap. A molecule that has a carbon-oxygen double bond located in the middle of a carbon chain. So we've got carbons on either side without any other oxygens in the molecule. That's a ketone. A reaction that converts an aldehyde to a carboxylic acid. An aldehyde converting to a carboxylic acid, that is an oxidation reaction because we're adding oxygen. A molecule that has a carbon-oxygen double bond located at the end of a carbon chain without any other oxygens. That is an aldehyde. A molecule that contains a nitrogen atom that is bonded to only one carbon, so that means it's bonded to two hydrogens. That will be a primary amine. The movement of small molecules across a membrane from high to low concentration, that's simple diffusion. A saturated triacyl glycerol. Let's come back to that. A carboxylic acid with a second OH group that's 2 carbons away. That's what we drew up here. A carboxylic acid with a second OH group that is 2 carbons away. That is our beta hydroxy acid. That is 23. An ester with at least one long carbon chain is a wax. A molecule that has a carbon-oxygen double bond adjacent to an OR is an ester. Movement of large molecules across a membrane from high to low is facilitated transport. A molecule that has a carbon atom bonded to an OR group and an OH group. A carbon atom bonded to an OR group and an OH group. Oh, that's a hemiacetal. 27, hemiacetal. A molecule with 3 carbon atoms and 3 OH groups. Oh, that's glycerol. I drew it on its side, but that's glycerol. 28. A reaction that converts a triacylglycerol to glycerol in fatty acids, that's hydrolysis. A molecule made from glycerol and 3 fatty acids is a triacylglycerol. A polyunsaturated, let's hold on to that one, triacylglycerol. An amine that is synthesized in the body to transmit signals through the nerve cells is a neurotransmitter. So let's see what we have left with. So we're looking at saturated and polyunsaturated triacylglycerols. And one of those is going to be a fat and one of those is going to be an oil. So let's kind of remember what that looks like, what it means to be saturated. Saturated means no carbon-carbon double bonds. And when you have no carbon-carbon double bonds, that's when you have those perfect zigzag tails, and the molecules can smush themselves very tightly together, and we get a solid at room temperature, which is a characteristic of what we would call a fat, like butter. Saturated triacylglycerol, that was number 22. So where's fat? And then polyunsaturated, that's one where we have a lot of double bonds in the carbon chain, which causes our carbon chains to be kinked up, not all straight, and it prevents them from packing together tightly, so they stay liquid at room temperature. So there's 31, the oil. And then what did I skip? A molecule made from glycerol, 2 fatty acids, and a phosphate group, phospholipid.